Async functions in JavaScript allow us to work with asynchronous code as if it were synchronous. Here, we define an async function named fetchData. Inside, we use the await keyword to pause execution until the fetch request completes. Once it's done, we await again to convert the response to JSON. This process looks like synchronous code, making it easier to read and maintain. If an error occurs, it's caught by the catch block, allowing for graceful error handling. This is the elegance of async, await in action. Here, we're transforming a promise-based function into an async, await pattern. The getNumber function returns a promise that resolves with the number 42 after a second. In the showNumber function, we await the result of getNumber. This await pauses the function execution until the promise is resolved, and then stores the value in number. Finally, we log this number to the console. By using async, await, we've made our asynchronous code more readable and much simpler to understand, similar to traditional synchronous code. Error handling in async, await is sleek and intuitive. In this example, we have an async function fetchData. We start by awaiting a response from an API. Notice the if statement checking if the response is okay. If not, we throw an error. This is a neat way to handle failed HTTP requests. Then, we await the conversion of the response to JSON. If any step fails, the catch block catches the error, allowing us to handle it gracefully. This pattern keeps our asynchronous code clean and error handling straightforward. In this example, we're demonstrating parallel async operations. We have two functions, fetchUser and fetchPosts, each fetching different data for the same user. Both functions use try-catch for error handling. In displayUserData, we await the results of both functions. This sequential execution ensures we have both user data and their posts before we proceed. It's a practical approach when one operation depends on the result of another. This code elegantly shows how async, await can simplify handling multiple asynchronous tasks in a clean and readable way. Here, we're harnessing the power of parallel execution with async, await. In fetchData, we're dealing with multiple URLs. Instead of awaiting each fetch call individually, we map over the URLs, creating a promise for each fetch. These promises are then passed to Promise.all, which awaits all of them simultaneously. This means our data fetching happens in parallel, significantly speeding up the process. If any fetch fails, the catch block handles the error. This approach is perfect for when multiple, independent asynchronous tasks need to be handled efficiently. In this example, we're comparing sequential and parallel data fetching. In fetchData sequentially, each URL is fetched one after the other. This means each fetch waits for the previous one to complete before starting. It's simple but can be slow. Contrast this with fetchData in parallel, where we create a promise for each URL and use Promise.all. This fetches all URLs at the same time, drastically reducing waiting time. By comparing the output of these two functions, we can clearly see the efficiency gains of parallel execution in asynchronous operations. Here we're exploring async, await within loops. We have a function, fetchUserData, fetching data for a single user. In process users, we loop through an array of user IDs. For each ID, we await the data from fetchUserData. This way, we're handling each asynchronous operation in sequence within our loop. It ensures that we complete fetching each user's data before moving on to the next. This pattern is useful when the order of operations matters, like when each step depends on the result of the previous one. Let's look at a common pitfall, forgetting the await keyword. In fetchData incorrectly, we've omitted await before the fetch call. This means the response variable holds a promise, not the actual response. When we try to call JSON on it, it leads to an error because JSON is not a method on a promise. Contrast this with fetchData correctly, where await is used properly. The response is awaited, and then the data is correctly extracted. This example highlights the importance of remembering to use await with async functions. Integrating async, await with traditional callback patterns can be a bit tricky, but it's absolutely doable. Take getUserData, a function using the old callback pattern with fetch. To use it with async, await, we wrap it in a promise within display user data. The callback either resolves or rejects this promise, allowing us to await the result of get user data. This approach gives us the best of both worlds, the familiarity of callbacks and the simplicity of async, await. It's a great strategy for gradually transitioning legacy code to modern async patterns. Async, await can be elegantly used in event handlers too. In this example, we attach an event listener to a button. When clicked, it triggers an asynchronous function. Inside this function, we await the fetch call to retrieve data and then await again to parse the response as JSON. This setup keeps our event handler clean and easy to read. If an error occurs during fetch, it's neatly caught by the try-catch block. This is a practical way to handle async operations triggered by user interactions, like button clicks.